In this video, we will be discussing the domain name system, or DNS, which is used to map IP addresses and their corresponding domain names into each other. DNS is a type of supporting application that works in the background to provide services to other applications such as email and the web. There are several applications in the application layer of the TCPIP protocol model, such as web, email, file transfer, and DNS. Each of the applications needs a protocol. For example, the web uses HTTP, email works with SMTP, domain name system uses DNS, and file transfer works with FTP protocol. In order to transmit their messages, these applications rely on the service of the transport protocols. For example, applications such as web, email, and file transfer are error sensitive. As a result, they use service of the TCP in their transport layer. However, DNS is delay sensitive, so it uses UDP for the fast transmission of its segments. Devices connected to the internet are identified with their IP address, which is a 32-bit unique address defined in the network layer. All devices and routers on the internet work with IP address. However, people prefer to use names rather than numeric addresses. IP addresses are hard to memorize for users. Domain names such as google.com are the human-readable equivalent of an IP address. The translation between IP address and domain name is done with the DNS. Most of the applications, including the DNS, follow the client-server architecture. This picture lays out how DNS elements work to resolve an address. Here we have a user who would like to access google.com in his or her browser. The user types the URL of google.com, and as the browser needs the IP address of Google, it will contact the DNS client. The DNS client, which is a process installed in the operating system of the user device, will contact the closest DNS server. The DNS server will look up the address in its database and then returns the address to the DNS client, and DNS client passes it over to the user browser. Now that browser has the IP address, it will go ahead and send an HTTP request for the homepage of Google using its IP address. The Google server sends back the copy of its homepage in an HTTP reply. All DNS requests and replies use UDP, but HTTP uses TCP. So this picture indicates how DNS helps other applications such as web and email to find their needed IP addresses. There are two approaches to address mapping, centralized and distributed. In the era of ARPANET, when the network was small, address mapping was done with a single host file that contained the domain names and the corresponding IP addresses. When an application needed to map a name to an IP address, the user device would contact the host file. It was a feasible and efficient method with a small network such as ARPANET. However, in the current internet, with billions of users, it is impossible to have addresses in a centralized location. On the internet, the domain information is stored in DNS servers scattered across the world. In this distributed approach, the host that needs mapping should contact the nearest DNS server to get the needed information. If the DNS server does not have the requested information, it will contact other DNS servers and then replies to the host. Now let's look at domain space and how domain addresses are defined. As the domain name is the equivalent of a unique IP address, it must be unique too. So domain names are organized hierarchically, in which the first part defines the nature of a business or organization. The second part is the name of the organization, and the next parts represent the internal divisions such as department and so on. Using this hierarchical and distributed architecture, the authority of each part can be assigned to the defined division. Assume we have two universities like Stanford and Berkeley, each of which has a science college, and inside that college, they have a computer science department. Berkeley and Stanford get their name from a central authority such as EDUCAUSE, which has a cooperative agreement with National Telecommunication and Information Administration (NTIA) for the management of the .edu domain namespace. Those universities can turn over the management of the internal domains to the respective departments. This way, divisions have control of their subdomains without interfering with other departments. This table lists some of the famous generic domain labels. For example, .com is used for commercial organizations, .edu for educational institutions, .net for network support centers, and .org for non-profit organizations. There is also a country domain category which uses two-character country abbreviation like .us for the United States and .ca for Canada.